What's going on, guys? Welcome back to this video. Today we're gonna again discuss and talk about threat hunting. Specifically, we're going to solve a challenge scenario. The challenge scenario name is EndGame. EndGame is a recent, it's not that recent actually, threat hunting game. It is part of the SOC 2 path. It contains particularly 3 tasks on solving the challenge using your threat hunting skills. So basically, first let's go over the principles and the theory, and then we're gonna apply it on practice. Okay, so remember that previously we talked a lot about threat hunting, and we defined threat hunting. We talked about threat intelligence and threat modeling. You can check out the playlist here that I have created recently. It contains everything there is to know and learn about threat hunting and threat intelligence. I'm going to put the playlist link in the video description. Okay, so let's not repeat the same thing over and over. Let's discuss new things now. Okay, so what we're going to do, basically in threat hunting, we're going to hunt for keylogging, exfiltration attempts, and data destruction. Now let's start with keylogging. It's the process of recording your keystrokes. So everything you type on keyboard is being logged to a database maybe, or it's being sent to a database where the hacker can read all of your keystrokes. So that's what is keylogging here. Now keylogging is a process that's carried out by what is called as keylogger. Usually, keylogging is a capability that comes shipped actually, or comes with the malware. So naturally, if a malware is installed on your system, it records your keystrokes, or it logs your keystrokes, or what is known as it keylogs your keystrokes. Everything you type on keyboard is stored in a file where the hacker can read this file and capture passwords, learn more about the system, so on and so forth. So keylogging is a capability that is performed by a keylogger. Sometimes keyloggers come standalone. Okay, so basically the attacker would send a file that is, or a binary that's specifically designed to be a keylogger. Okay, or sometimes, or some other times, the attacker would send the binary or the malicious file as a complete set of capabilities to act as a malware. Malware naturally records your keystrokes or act as a keylogger. That a malware is a keylogger, but a keylogger is not a malware. It's a type of malicious software. It's considered as a malicious software, but it is not a complete malware. Okay, so how keyloggers log your keystrokes? So basically, first, it is done mainly through API calls or system calls. On the second degree, it is performed by doing registry modifications. I'm not going to list all of the techniques used by keyloggers, but mainly for this scenario, it's worth knowing that keylogging is performed by doing API calls and registry modifiers. Alright, so the thing is, as a blue team analyst or as a threat hunter, you want to discover signs of keylogging or the presence of keyloggers by monitoring API calls or registry modifications. You will want to track certain API calls or certain modifications. For example, when it comes to API calls, some of the API calls performed by keyloggers, the first one is vkey to get access to the keyboard. The other one is draw text. These are some of the API calls that are requested by keyloggers. So by investigating these API calls, you will be able to find signs of keyloggers on the system. All right, the next thing we're going to discuss is the exfiltration. So basically, as you know, guys, exfiltration is the process of channeling data from the target machine to the C2 machine or the attacker machine. So I'm not going again to go over this. repetitiveness is not good. So basically, we can go back to previous videos and understand what is exfiltration. We can find signs of exfiltration using threat hunting techniques. But how to do that? We're going to look at the usage of basic system tools to perform the exfiltration. Some of the system tools that are used in exfiltration is ping. Yes, ping can be used to transfer data. Additionally, we have netcut, and we have wget, along with cur. These are system tools that attackers may use once they get access to your system. So why would the attacker use the system tools instead of relying on their own tool? Because they don't want to trigger the antivirus. If you have antivirus installed and the attacker transferred their own tools to your system to steal data, most probably your antivirus will raise an alert. So instead of doing that, they would use the built-in system tools to perform the exfiltration. So to hunt or look for signs of exfiltration on the system, we're going to look at signs of using these tools or weird usage of these tools. Because sometimes administrators would use these tools for administrative tasks. Okay, so it is not that exclusive to the attacker if they use these tools. It's not exclusively malicious. But we need to look for the usage of these tools and see if it is authoritative or if it is under the context of system administration. And lastly, we're going to detect or look into data destruction. So data destruction here is a technique considered one of the MITRE techniques. Basically, all of these, keylogging, exfiltration, and data destruction, are considered as attackers' tactics and techniques. They can be found or referenced by the MITRE framework. So when it comes to data destruction, the attacker would attempt to destruct data on your system after they get access. It depends on their objective. So some attackers or some hackers would want to get access to your system for the sole purpose of destructing data. Now, there are many methods of destructing data. One of the most popular methods of destructing your data is using ransomware. And it is a very popular method. So the attacker would send you a malicious file where you open the attachment or download the file, and after downloading the file, your system gets infected with ransomware where all the files or all the system is encrypted and it's only decrypted after you pay the ransom. In case you don't pay the ransom, your system would still would stay encrypted and you will not get access to that. That's why we call it data destruction. Now in threat hunting, we can detect the presence of ransomware and we can detect the other tactics of data destruction, such as deleting restore points and shadow backups. So restore points are methods of creating backups of your data on Windows systems. And same for shadow backups. When an attacker attempts to delete restore points and shadow backups, we call it data destruction. So in threat hunting, we want to look for signs of data destruction using these methods. So how do we do that? Basically, we need to take a look, or we need to look for signs of using the relevant tools used for creating system restore and shadow backups, such as the shadow tool in Windows. It can be used to create shadow backups, but it can also be used to delete shadow backups. Additionally, we have BCD edit, and we also have other tools such as RM, delete. These are command line tools in Linux and Windows used to delete files. All right, so now we're gonna discuss how we're gonna do all of this from a threat hunting perspective. Now, in threat hunting, we need what is called as a data set. Now, remember previously when we talked about threat hunting, we discussed that data set is mainly a set of logs. These logs can be from the web server, can be from your Windows system, event logs, can be Linux authentication logs, so on and so forth. By investigating these logs and looking into the events, we will be able to look for signs of these attackers' tactics and techniques. After you deploy the machine, navigate to the IP address given, and you can log into the Elastic Stack instance. So we go to Discover and click on Show Dates, use years, and make sure it is set to last 15 years. So as for the data set or the index, we're gonna first select case collection, update, make sure we retrieve the events, and we have around 7,944 hits. So now we get started. But the first thing we want to do, remember, first we want to investigate the presence of keyloggers. To do that, we're going to rely on signs of using keylogging. Remember, keyloggers use API calls and registry modifications. So we're going to need to first find out what are the API calls used by keyloggers. It's basically in the task 4, they are listed, so you can use them in a query here. As you can see in this query, we're looking for these strings. These are the API calls used by keyloggers. So we can look for the signs of using these API calls, and we use the OR because we want to spot the events containing one or more of these API calls. Gonna click on update. And we see we have 4 hits. Okay, before we start investigating, we need to remember when using Elastic Stack, it's very crucial to use the fields or the filters effectively. So we want to understand where do these events come from. So first we're going to add the winlog channel. So as you can see, it appears now as a column. And we're going to add, we don't need the computer name, the command line, not necessary for now, although it is useful. We're going to need to add the path. So here we see the path of the file. And since we're looking at PowerShell events, we're going to need to add the, we're going to check out the full PowerShell command. So we're going to take a look at the script block. So in script block, we have 2 data script block DID and the script block text. We're going to add the script block text. Okay, so as you can see, guys, the logs come from the PowerShell Microsoft Windows PowerShell. Indicates the use of PowerShell. And under this column, we see the PowerShell script used. So the name of the PowerShell script is Chrome Update API. Scrolling down, we see only these 3 scripts. And here we see the script block. You can expand this or view the surrounding document. Take a look at more details. So this is the full script block. Okay, we can still go back. Okay, so now we know that the PowerShell script is part of the API call. As you can see, we have the virtual key code performed by this script. So this script is responsible for performing these suspicious API calls. So to investigate further, we will want to put the name of the script. Now take a look at this. The path here. So start keylogger. This is the name of the function, and this is the path. Looks like this is the file where it stores the keystrokes. So Chrome local profile DB, this is the database. Usually keyloggers store the keystrokes or the recorded keystrokes into text files or databases. Okay, so now we want to find out the root causes. Where does this PowerShell script come from? And we want to find the originating processes. To do that, we're going to use the name of the PowerShell script along with the name of the database in a new query. update, and we have 14 hits. Okay, scrolling down, look at this. There is this command, cat Chrome local profile. This command is used to view the contents of the database. Probably here the attacker wanted to check the recorded keystrokes. To understand the chronological order of the events, it's very recommended to use an ascending order. So this way we sort the events correctly. Okay, so as you can see, this is the first instance. Here a wget command was used to download the PowerShell script from this address. So now, as a threat hunter, you stumbled upon the first key piece of information, which is an IP address and port. Okay. Now, usually when doing threat hunting, mainly we look for indicators of compromise, IP addresses, domain names, hashes, file names, etc. So this is the IP address from which the PowerShell script was downloaded from. Going over with the events, here next we can see the execution of the PowerShell script. Scrolling down, we can see later down the road, the attacker tried to view the contents of the database. So we need to view more details about this command. So basically here we're going to add a new column, and the new column name is payload. Okay. Now the next thing we want to do, we want to use a filter. So in the filter, we're gonna look for all the events where the name of the database appears. And we're going to use this column name as a filter. So in the query, we're gonna write, let me copy the command first. Okay. So here we use this column, and we want to narrow down the events where the name of the database appears. Gonna update. And here at this command, we're gonna drill this down and take a look at the view surrounding documents. Okay, so in the view surrounding documents, we want to see the keystrokes. I'm gonna increase this to 20. Okay, look at this. Command invocation, parameter binding, how to open incognito tab, Gmail. And we see email addresses, and we see what might appear as passwords. Again, we have the same here. So now we are able to see the keystrokes, guys. Okay, so now let's open task 4 and answer the questions. What is the process ID of the process that downloads the malicious script? Remember that the process that downloaded the malicious script was wget. Before answering this, let's answer this question. What is the logged mail account? You can find the logged mail account from here, from the keystrokes. It is huntedvictim@gmail.com. Let's answer this question now. I'm going to go back. Okay, so using this query, we can see that the first event in the chronological order of the events, we can see it highlights wget. To find out the process ID, we're going to drill this down and take a look at the process ID. And this is the process ID. In the next task, we're going to look at the exfiltration. Task 5, looking at the exfiltration attempts. Let's go back here, and now we're going to need to change the index from case collection to case exfiltration. Okay, and remove this query. Click on update. Okay, we have around 241 hits. You can also reset the columns. We're going to reset these. Okay, now remember that in exfiltration, we said that the attacker might use system tools, Ping, Netcat, wget, cur, and other tools to perform the exfiltration or the smuggling of data from the victim machine into the attacker's machine. So we're going to need a full or a one full query here that we can paste in the search bar and look for signs of using such tools. So this is the query. As you can see, it highlights the tools that can be used for data exfiltration. Apparently these are system administration tools, as stated earlier, but the attacker would or might use these tools for their advantage. I'm gonna click on update. And see. So you have one hit. It comes from Windows PowerShell. Or the channel is Windows PowerShell. Let's take a look here. One event, and this is the text of the data. As you can see, ping was used. New object, to create a new object, system networking information. So here we can see that there is one use of ping to transfer data. What we can do, we can take a look at the event data path or add it to the list of columns. Okay, and there is nothing here. Okay, what about if we copy this? Let's see where it is. Yeah, this one. Let's copy that. And we see all the events that use this object. Click on update. We have 5 hits. And looks like there is a PowerShell script named ICMP4 data, and this might be the PowerShell script that was used to perform the exfiltration through the ping tool. Now what we're gonna do, guys, we're gonna need to add another column here, which is the script block text, to take a look at the contents of the script. And we see the contents, and it indeed used ping here. There is IP and there is file. Probably this is the file that the script exfiltrates, and this is the IP address or the IP of the C2 server. Apparently, to take a look at more details, you can do view surrounding documents. Given that we have enough events, click on 20, and they are sorted in an ascending order. Apparently, no. Okay, we're gonna start from down there. Look at this. So this is the script, okay, and it is actually exfiltrating the database that stores the keystrokes. Remember that the attacker used keyloggers to record the keystrokes. Now the attacker is sending the file or database file that was created on the victim machine to the C2 server. This is the IP address of the C2 server. Okay, now let's see the questions. Task 5. What is the total number of ICMP packets sent? All starts out here. And here we can see the contents of the PowerShell script. Let's take a look at more details. View the actual contents. As you can see here, it calls ping, and this is the chunk size or the byte size. So the data is carried in a chunk size of 15 bytes. Maybe this answers the second question, not the first one. Okay. Okay, so this shows the contents of the PowerShell script. Let's look at the other event. Okay, the other one here looks like the start of the transfer of the packets. Click on this arrow. We can see here these are the ping replies. Now if you count them, you'll be able to get the count of the ICMP packets. So the number of these represent the count of ICMP packets, and they are actually 21. Now how many bytes chunk is the amount of data carried in each packet. We already said it's 15. And next, what is the name of the exfiltrated document? We already answered this. It is the local database. If you paid attention, if you paid enough attention to the explanation, you will remember that we answered this question. And lastly, what is the server's IP address where the exfiltrated document is sent? We also already answered this during the explanation. Now, the last thing we're going to discuss is the impact. Now, impact, it is the technique in reference to MITRE, ATT, and CK, where the attacker will attempt to destruct data using ransomware or by destroying backups. Let's see now how the attacker would do that in a real scenario. So first, we're gonna reset the index, change it to case impact, and update or refresh. Oh, we're gonna first also we're gonna have to reset the query, update. Okay, we have 377 events. Remember that in this scenario, we're looking at size of using system tools, specifically the tools used for backups or for creating backups and system restore points to actually delete data. So to do that, we're gonna have to create a query that encompasses all these tools, including the tools used for deleting data, such as del and rm. So that query here, we can use it to look for size of using one of these tools, one or more of these tools. Update, and we have 64 hits. Let's sort these out. So we're going to delete the payload. We're going to delete the script. We're going to keep the script to block text, data path, and winlog channel. Oh, okay, since we have 64 hits, it means we have a lot of events. So to make sure that we're looking at the right events from the right Windows channel or the log channel, we're going to have first to save this query, okay, and use statistics or visualization to see where most of the queries come from which log channel. Do they come from partial? Do they come from other channel that we don't see here? So we're going to save this and name it as impact. And we're gonna click here, go to visualization library, lens, and here use the drop down and click on impact. We select table since it is the most appropriate type of visualization to view statistical information. So table, and here we're gonna look for log channel. We don't have. Oh, change the index to impact. And then I think we will be able to see channel, refresh. Okay, so most of the events come from the partial with 38 events. And from sysmonitor we have 18, from security we have 5, and from system we have 3. Okay, so which log channel is the correct channel to look at? Actually, it is the security. Why? Because we're looking at the usage of these system tools. The usage of such system tools can be viewed or is audited or recorded in the security event log. So we're going to need to take a look at the security event log. To do that, we're going to have to go back to discovery, okay, add a filter. From the filter we can use win log channel, select is, and the name or the value is security. We should get 5. Indeed, we get 5 events. So since we're not looking into partial events, we're going to delete the path and the script block text. What we want to add is the event data command line. The process ID would prove to be useful. The path, okay, we can add this as well. Payload, we don't need payload for now because it's not partial. And the path, okay, we're going to keep the path. Okay, so if we sort the events in an ascending order, we can see the first event uses the VSS admin to delete shadow copies. So that's the first sign of using system tools to delete data. And this is the process ID, as you can see here. Now, we can also use image to view the original executable name and the parent image. Apparently, there is nothing. Most interesting event here is the use of VSS admin to delete shadow backups. And we can see this is the process ID. In threat hunting, we look to investigate the root cause of the malicious event or the malicious process. So we're going to take a look at, or we're going to use the process ID here to find more details. Okay, so when event data process ID, the name of this column can be used as a filter in the query here. And the process ID is 1972, update. Okay, look at this. So we have the use of VSS admin, and we have another event that uses the command line. Okay, so see here. Okay, and now we can see there is a process okay, now with the filter working, now we can see that there is a new entry that preceded the use of VSS admin. Here we can see a command line interpreter was used, and that was the parent image. It is PowerShell. So PowerShell was used to launch command line, and from the command line, the VSS admin tool was used to delete the backups. Okay, now let's see the questions of this task. What is the name of the system executable used to remove shadow copies? It's very clear. It is VSS admin. And what's the main shell image that started the attack chain? It is PowerShell. And lastly, what is the process ID that started the attack chain? We need to find the process ID of PowerShell. We can drill down here for more details. Scrolling down for the process ID. When log event data parent process ID, it is 6512 or 6512, and that marks the end of the challenge. I hope you guys found this helpful, and I'm gonna add this video to the playlist of threat hunting. If you want to learn more about threat hunting, you can check out the playlist. That was it for today. I'm gonna see you later.